Space, the final frontier, where the USS Enterprise carries out its 15-year mission to discover new worlds.
Captain's log, stardate 5017.3. We may die, as we have found a mysterious foreign object, which is absorbing our power.
There's some sort of foreign object approaching.
It seems to be a space amoeba.
Captain, we're approaching the amoeba. What are we to do?
We need to perform protein synthesis.
What do you mean perform protein synthesis?
Well, protein synthesis produces proteins that can help the organism create enzymes, which in turn produce chemicals to create energy. It seems the organism is out of energy and is trying to take our own.
So how do we do this?
We need one of our crew members to go out to the nucleus and act as mRNA to stop it from draining our power.
Uhura?
I'll send the word.
What's wrong?
Oh, I'll be fine. I just feel a bit...
Oh my goodness! McCoy, Christine, your assistance is needed in the bridge.
What is it? What's wrong?
Uhura fainted, probably due to the space amoeba.
Oh.
Thank you.
Oh. Here, this should stop you from fainting again.
Thanks.
This thing is killing us. It must be destroyed.
Captain's log, stardate 5018.1. The nucleus is absorbing all of our power. We don't have much time left. I now have to make a very difficult decision. Which of my friends will I condemn to death?
I will need one of you to go into the nucleus and copy its antisense strand. We need its code to make a protein so that we can gain enough energy to destroy it.
I should go, Captain. I am the right person for the job. I am the doctor of the Enterprise, and as such, I know more about biology than this man here.
I believe it would be better if I went into mRNA. I would base my decisions off of logic, not human emotion.
I agree. All right, Spock. You're on your MRA.
I will depart immediately.
Spock, are you ready to leave in the RNA polymerase? You'll be leaving as soon as possible.
The RNA polymerase is ready to launch. I will depart on your order.
Thank you, Spock. Now, launch.
Launching in 10, 9, 8, 7, 6, 5, 4, 3, 2, 1.
Mr. Spock, can you hear me? Are you alright?
Yes, I'm fine, but McCoy, you would not have survived that. I have found the nucleus.
Good. Have you found the antisense strand?
Yes. Now, Kirk, just so that you may follow along, I have given Janice a video on protein synthesis. I suggest that you watch it while I perform the actions.
Got it, Spock.
Here it is, Captain.
Thank you.
Hi, my name's Anna, and this is Nicole, and we'll be telling you about protein synthesis. Protein synthesis is the process by which the cell creates proteins to carry out their structural and functional jobs.
Proteins are a polypeptide bond made of amino acid. Protein synthesis always begins in the nucleus and starts with the antisense strand. The code for our antisense strand is TAC, GAG, ACC, CAT, GAA, and ACT.
The next part of the process is finding the sense strand that corresponds with the antisense strand. The code for the sense strand is ATG, CTC, TGG, GTA, CTT, and TGA.
The next step in transcription is the RNA polymerase unzips the DNA double helix. The code from the antisense strand is used to make mRNA. The code for mRNA is AUG, CUC, UGG, GUA, CUU, and UGA.
The 5 specific steps in transcription are as followed. First, enzymes unwind the DNA.
Captain, enzymes have successfully unwound the DNA. I can clearly see the antisense strand.
2. The RNA polymerase recognizes a specific base called a promoter, and it binds to it. The promoter identifies the start of a gene, what strand to be copied, and the direction it's supposed to be copied in.
3. Complementary bases are assembled using U instead of T. A termination code in the DNA indicates where the transcription will stop.
The mRNA produced is called an mRNA transcript.
All of the protein transcription happens in the nucleus. When antisense strand is done being copied, the DNA winds back together. Transcription is finished when the mRNA strand goes out of the nucleus and into the cytoplasm.
An intron is a segment of the mRNA that doesn't have genetic material and it is removed before translation begins. An exon is a segment of the mRNA that has genetic material and it is kept. After introns are removed, the mRNA is called a mature mRNA.
Captain, I have the code and I am now leaving the nucleus.
Now that we have completed transcription, we must move on to translation in the cytoplasm. The codons in the mRNA correspond with the anticodons in the tRNA triplets. They are UAC, GAG, ACC, CAU, GAA, and ACU. Translation happens throughout the cytoplasm, but mainly in the ribosome.
The first step in translation is for the mRNA to find a ribosome. Ribosomes are composed of rRNA, or ribosomal RNA. The two halves of the ribosome form around the mRNA.
I am in the ribosome, Captain.
Then the tRNA bonds with the mRNA in the ribosome, and the amino acid carried by the tRNA is deposited.
This happens for every codon, which is every 3 complementary base pairs, and the amino acid that is left behind forms a polypeptide bond or protein.
Initiation and termination codes have been formed so that translation will go smoothly. Initiation codes tell the ribosome where to start and termination tells it where to stop. The amino acid chain is as follows: methionine, leucine, tryptophan,
and valine, leucine, and the termination code. Hopefully these basic steps on protein synthesis will help you in whatever you need to do.
Captain, my work is complete. I'm now departing the probe.
Let's check in on Spock.
Open the loading deck, please.
Scotty?
Aye, Captain. Spock is no longer with us. And you're...
Yeah, I had to mark it twice because it was off.
Hey, what are you guys doing?
Hey, step back. Step back.
Oh, Jesus.
Thank you.